So next we'll move on helical gear. So example 4.17, a pair of carefully cut class 3 helical gears for a turbine has a transference ratio 10:1. The teeth are 20 degrees stub, involute. Pinion has 25 teeth, rotates 500,000 rpm, metal pinion, and gear is 4.4% carbon steel. Determine the modular number of pin, diameter plane, and face width of the gears. Suggest suitable hardness, modular service stretch. Taken a student GP, helical 30 degrees, power transmitted 900 kilowatt. So data as the given: I is 10, N1 is 5000, alpha is 20 degrees stub, Z1 is 25, E1 E2 is 210, beta helix angle 30 degrees, power 90 kilowatts. Now using the velocity ratio I, N1 by N2, Z2 by Z1, D2 by D1. So speed of gear N2 equals to N1 by N1, so it's 500 rpm. Number of teeth on the gear Z2 is 250. Now from table number 23.48, sigma 1, sigma 02, 69.6 for 0.4% carbon. Formative number of teeth ZV, so ZV1, Z2V, Z1V and Z2V. We have the formula Z1V cos Q beta and Z2V cos Q beta. So we have 38.49 and 84.9. So Levy's form factor for 20 step Y is 0.710 ZV. So substituting the values of ZV1, Z2V, we have Y1, Y2. So as we know, both members are same material, then this is a may become member. Tangential load FT 950,000 and CSNR N1 R1, R1 is D1 by 2, MZ1 2 cos beta. So we have 14.4 MN. Then CS we get it as 1.25 or 1.5. Then we have first equation 14886.98 MN, and Levy's equation for tangential load FT sigma 0 by P and KB by CW. So CW became is 1.25 and B is 10 atm. Substituting all these things, we get 254.2 mn square kV. Second equation equating 1 and 2, we have m cube kV as 58. So this velocity VD pi d 1 in 60,000. We have 7.5% mn. So trial 1 model mn equals to 5 mm. So we had BM equals to 37 point, which is greater than 20. So we can use the formula 5.6 by 5.6 plus root of VM. So we get 0.4767 as velocity factor. Substituting this, we get it is more than since it is suitable. Then we'll try a lesser one. So trial 2, we take it as 4. So as we substitute VM, we get 30.23. Then we get KV 0.0546, which is less. Substituting this, we get less than the 58. Then it is not suitable. Switching for stress, sigma allowable sigma 01 kV and sigma induced FT CW open BY on PN, we get 32.61. Dividing this two, we get the FOS as less than 1 and more than 1. It is suitable, hence the face width is 50 mm. So now dynamic load FT plus 21 VM cos beta. So with this equation, we know this equation. So from this we get the so class K we get F as 0.025. For this F 0.025 we get C as 300.2 kN per meter. Substituting this in the equation, we get FD as 13,693.93 newtons. The wear load FW D1 BKQ cos square beta. So substituting the values of D1, we get 144 Q as 1.8182 and so K we need the K. Then substitute FWFD, we get the surface fatigue as 580. So for this 580, the surface is 300 and 200 BHN.